Hi, pre-calculus. We are going to go over closure. There we go. Chapter 8, closure. Okay, so 158 asks us to simplify this expression here, to rewrite it as a single trigonometric expression. So, and remember, for all of these, there is more than one way to start it and still get to the correct answer. What I did was I decided to rewrite the secant of x as 1 over the cosine of x. And then I still had the minus the cosine of x. And then I had all over, and then I still had my sine of x in the denominator. Then what I did was I got a common denominator on this top part. Yeah, that's what I did. Sorry. So I multiplied here the top and the bottom by the cosine of x. I was debating on supergiant 1, but we don't really need one since there's only the one fraction. So when I do that on the top here, I'd have 1 minus cosine of x times cosine of x is cosine squared of x. And then it's all over the denominator of the cosine of x. And then that whole thing is over the sine of x. Now, when I'm dividing by the sine of x, that's the same thing as multiplying by 1 over the sine of x. So dividing by sine, I can think of it as dividing by sine over 1. So I'm going to kind of do two things at a time, right at one time now. First of all, this 1 minus cosine squared, that's equal to the sine squared of x. Over, I still have this cosine of x. Okay, so I'm just going to use color so we can see where things are coming from. Okay, so this right here just came down. Okay, this right here became the sine squared. And then I have it, instead of dividing by the sine of x, I'm going to multiply by 1 over the sine of x. Okay, so this just multiply by the reciprocal instead of dividing. Okay, now what I can do is from the top and the bottom, I've got sine squared over sine of x. That's just equal to the sine of x, right? It reduces by 1 because this is like sine of x times the sine of x. So 1 cancels over the cosine of x. And sine of x over the cosine of x is equivalent to the tangent of x. Okay, making sure you're showing all your steps all the way through. All right, 159. So solve for the specified value given the information provided. Assume that the angle falls between 0 and pi over 2. So that just means if you were thinking about a right unit circle, it's something in the first quadrant. So if the cosecant is root 5 over 2, find the sine. Remember, cosecants and sines are reciprocals of each other. So if I know the cosecant, then the sine is just the reciprocal. Now we always want to simplify. We don't want to leave a radical in the denominator. So we call it rationalize the denominator, right? Root 5 is an irrational number. To rationalize it, I multiply the top and bottom by root 5. So I'm left with 2 root 5 divided by root 5 times root 5 is root 25, which is just 5. Okay, for part B, I'm given the tangent of the angle and ask for the cotangent of the angle. So it is again the reciprocal. Now sometimes with that 0.8, I might rethink of that as 4/5, or you could start with it's 8/10, and 8/10 reduces to 4/5. And then when you go to find the cotangent, it's just the reciprocal of that, which is 5/4. If you wrote 1 over 0.8, really we don't leave it with a fraction and a decimal. So you want to divide that out. You could say it's also 1.25. Okay, for part C, I'm given the cosine of the angle is 3/5, but I want the sine of the angle. So those are not reciprocals of each other, but I know I have an angle that is in the first quadrant. So I know I have an angle in the first quadrant where the cosine, the adjacent over the hypotenuse, is 3/5. So I could label my angle. Here's my adjacent. Here's my hypotenuse. Okay, there's a Pythagorean triple, 3, 4, 5, where if I know one side is 3 and the hypotenuse is 5, this has to be 4. So this would be then opposite over hypotenuse, which is 4/5. The other thing you can always do is just do the Pythagorean theorem and get the 4 that way. Now you also could have gotten your sine using, if you wanted to, the Pythagorean identity, right? Because sine squared plus cosine squared is 1. And you could have solved to get the angle, and like done 3/5 squared, and you could have gone through and solved. Oops, my equal here changed to a plus for some reason. Let's fix this. This is plus, this is equal to 1, and you could solve that, but that seems like a lot more work than this was. All right, and then for part D, they give us the cosecant of an angle is √5/2, and now we want the cosine. So again, there's not a direct relationship between cosecant and cosine, but I could do sort of the same thing I did over here. And I know I have a first quadrant angle. If it's cosecant, that's reciprocal of sine. So it's hypotenuse over opposite. So my hypotenuse is √5. My side opposite is 2. And then I could figure out this side. Now this isn't any sort of special triple. So I'd have to do something like a squared plus b squared equals the √5 squared. So I'd have a squared plus 4 equals 5. So a squared is 1. So a is positive or negative 1. And because we're in the first quadrant, this would be 1. And I want cosine, so adjacent over hypotenuse, so 1/√5. And again, I can't have a radical in the denominator, sort of like in part A. I would have to multiply the top and the bottom by √5. And then I would get √5/5. All right, let's move on to 160. 160. Oh, you probably looked at this and were like, ugh. All right, so they give you all this data to represent the approximate water level in feet at any time where T is the time after 5 a.m. So first of all, it's important to note that T is the time after 5 a.m. So when we graph this, we don't want to start at 5. We want the time after 5 a.m. So like this is 0, 1, 2, 3, 4, and so on. So when we put the time in, we want to be careful about that. And then we're going to write an equation and all that. So it would be helpful to look at the graph. And I did put the graph into Desmos to make our lives a little bit easier as far, you didn't have to plot every single point. So it looks like this. So we want to figure out, okay, what's the amplitude, what's the shift, and so on. So I kind of see my middle is like 15-ish here. So it sort of seems like my sine is starting here at 1, right? And so I could do, to get my amplitude, so it's like from 10.2 to 20. Now you could do it exactly and do 20 minus 10.2 and figure out that's 9.8 and divide it by half and say 4.9 for your amplitude, right? Because if this is from about 10 to 20, it's about 5. Or you can just say 5 for this one, because we do have this one goes a little bit higher. It is data, it's not going to be perfect. So I would say it's a flipped sine. The amplitude is 5, right? 5 up, 5 down, the vertical shift of 15. The horizontal shift is here at 1. And then how long does it take to complete one cycle is about 12 hours. Okay, so we're going to use that to get our equation. So we said our amplitude, let's go back to the pen here. Our amplitude is 5. Our vertical shift was 15. We had a horizontal shift of 1, and our period was 12, but I need to know B. So if I multiply both sides by B, I get 12, B equals 2 pi. So B is 2 pi over 12 or pi over 6. So it was a flipped sine. So I would have y equals negative, my amplitude was 5, sine pi over 6 times t minus 1, and then plus 15. There would be my equation. All right, and then part B says Otis's girlfriend wants to know for sure that he is really at the dock of the Crystal Bay. So she asks him the water level at 7:30 p.m. So 7 p.m. is right here. So you have to think how many hours was that since 5 a.m. And I want to know 7:30. So, and it might even help to look back at our data over here, right? to figure out what we want to substitute in. Okay, so, and we want PM, right? So PM was here. This is the data for 7 PM. So 14.5 is what we would want to plug into our equation. So this was at 7 PM. That's 14 hours after. If I want 7:30, I want to know 14.5. So into this equation, and it's going to be important here because that's a pi over 6. And I know this is really annoying because your calculator is probably in degrees. And for most everything else, you want it in degrees. But here you need this to be in radians, which is annoying to have to go back and forth. All right, so you should get about 11.46 feet for this. Okay, and then it says while Otis is sitting, he noticed the water goes past the 14-foot mark several times. Using your model, determine all the times in the first 24 hours when the water reaches the 14-foot level. So then into our equation, and this is like what we did in, was it 8.1.2 when everybody did their little presentations, the solving process, it's the exact same. So I would subtract the 15, right? We all did this. I would divide by the 5, so I'd have 1/5. This looks like 11, but that's a parenthesis. I'm writing too fast. I would take the inverse sine of both sides. And I'm just going to do this. I'm just going to say I'm taking the inverse sine here and I'm taking the inverse sine here. And when you do that, I wrote this down. When you do that, you get 0.201 equals pi over 6 times t minus 1. And then when you multiply both sides by the reciprocal of pi over 6, so 6 over pi, then you get 0.384 equals t minus 1. And then you add the 1 and you get 1.384 hours. So 1 hour and 384 1,000th of an hour. I want to know how many minutes this is. So I'm going to multiply this by 60, and that's equal to 23 minutes. So 1 hour and 23 minutes. Okay, well, if you think about it, we started at 5 a.m., 1 hour and 23 minutes from 5 a.m. would be, so if I add 5 a.m., it would be 6:23 a.m. They did say every time it happens, I'm going to go ahead and turn my equation on. Every time it's 14. So just to kind of get a look at what it is. So here, right? So I could add that, and again here, and again here, right? So I could just keep adding. That's past 24 hours left. All right, so you could just keep adding that amount to get the different times. So it ends up also being at 6:23 a.m., 6:23 p.m., 11:37 a.m., 11:37 p.m. So if I'm at 5 a.m. and I add this 6, then it's 11. All right, so let's see what we have next. All right, so now we're given equation or given graphs and we're asked for equations. Now remember, for all of these, you could see all of them either as a regular sine. So you could look for a regular sine cycle. You could look for a flipped sine cycle. You could look for a cosine. Or you could look for a flipped cosine. And you could find any of them, and sometimes they have a phase shift and sometimes they don't have a phase shift, if at all possible. I try to avoid, when I say phase shift, I mean a horizontal shift. I try to avoid it if I can. So if I look at just starting from the y-axis, this right here, if I start and I trace this, and see how that looks like a flipped cosine. And if it's starting right on that y-axis, then I don't have to worry about a horizontal shift. So I'm going to go with that. And then this is down at -4 and this is up at 2. So halfway would be -1. That midline is my vertical shift. My amplitude is, I'm going up and down 3. So I have an amplitude of 3. My period, the horizontal distance it takes to complete one cycle, is pi. But I need to know b. So 2 pi over b equals pi. So that means b must equal 2. So I'd have y equals, it's a flipped cosine, so -3 cosine of my b is 2. So 2x and then plus a vertical shift of -1. So actually I want minus 1. Right, a vertical shift of -1. Okay, so that would be my first equation. All right, now when I look at this one, I feel like I'm not getting off so easily where it's starting, you know, my cycle right on the y-axis. I think it might help me right now to draw in my midline, which appears to be here. Then I can sort of look a little bit more easily for where does a cycle seem to be starting. And it doesn't seem to be starting right on a nice grid line. So let's see, if this is 2 pi and then this is 1 pi, I could see a negative cosine here starting, it looks like pi over 4, maybe, or I could see a positive cosine starting right here, right? Like I could see a cycle of the cosine starting here with maybe a phase shift of what is, if this is pi, that's maybe 5 pi over 4. I could think of it as a sine that's starting right here, right? A sine right here. If this is pi, that looks like what, 3 pi over 4. So there's so many different ways I could write this equation. My amplitude is 2, my midline or my vertical shift is -2. I think I'm going to go with, after all this talk here, answer the book gave was they saw this. So I'm just going to be consistent with that. So you see where they got that answer from. And they thought, okay, if that's pi, that's 3/4 pi, and it went to the right 3/4 pi. So they said a horizontal shift of 3 pi over 4. And my period to complete one cycle seems to be like starting here and ending here, seems to be a period of 2 pi, which is nice because then I don't have to mess with that b value. Okay, so my equation would be y equals 2 sine of, I don't have a b value, so I could just have x minus 3 pi over 4 and then -2. All right, so now this one, right, that's a secant or a cosecant, right? And remember that like when we figured these out, they were based off of a sine or a cosine, and that might help you just looking at it. And remember what it was is that like they touched here and here and here. So like if I have to have a graph that touches here and at a maximum and then comes down and kind of goes like this and then comes back up and goes like that, like what shape is that? That looks like a cosine. So then this must be the graph of the secant. All right, now this one you have to dig deep for. This is way back from first semester. This is the graph of the inverse tangent. Okay, so if we think about how we know a tangent, one cycle of the tangent looks like this. And we know that inverses are reflections over the line y equals x. That would give me this. So I don't know, you might have struggled with that one. I wouldn't worry too much about that on the test, but that's where that comes from. All right, 162, ooh, piecewise. This is also from first semester having to graph it. We looked at piecewise a lot this semester when we're talking about continuity, but the graphing of it, it's kind of been a while. Okay, so when we go to graph this from, for x values less than -1, our y values are x squared. And a lot of times when we would do these, we would make little tables, and this would be for when x is less than 1, and the rule is y squared. And we would start at -1, even though it's supposed to be less than -1, because that's our boundary point, we would just put an open circle at that value because it's everything up until the -1. So this would be 1, and I want values less. So like at -2, it would be 4, at -3, it would be 9. And so this graph, so at -1, it's 1. So I'd have an open circle here. At -2, it's 4. At -3, it's up here, it's 9. So back here, it's like a little piece of a parabola here. Okay, and then it's x cubed. So our rule is y equals x cubed for x values from -1 to 1. So I might just do -1, 0, and 1. And it's, so from -1 is less than or equal to x, is less than or equal to 1. So it would be closed circles here and here. Whoops, I don't know why I put that for this one, for the endpoints, and then it would be everything in between. I might actually do this in blue, just so you see it in a different color. Okay, so when I put -1 in here, I get -1. If I put 0, I get 0. If I put 1, I get 1. Okay, so at -1, I'm at -1 here, 0, 0, and then 1, 1. Now it's not a line. Remember, things that are cubic, the parent function is like, whoops, kind of like this, right? Okay, so there's like a point of inflection there. Okay, so that's that little section. And then finally, this last part, and let me do this in a different color here. It's just x and then y equals 1 for any x value bigger than 1. So when I make my table at x equals 1, it's an open circle, and then it's 2, 3, 4. No matter what my y value is, it's just a horizontal line. So it's kind of like, I know it's an open circle on top of that blue one, and then it's just a horizontal line to the right. So that's what that graph looks like, kind of nutty. All right, so then now we can talk about continuity. So for part B, is f of x continuous at x equals 1? Okay, so continuous at x equals -1. And also you want to know, is it continuous at x equals 1? Use the formal definition of continuity, justify your answers. So at -1, you might look and say, oh, there's a break in the graph, it's not continuous, but we have to go through the continuity test. And the first part is, does f of -1 exist? Is there a y value when x equals -1? Yes, it does, right? F of -1 is -1. So it meets criteria 1. The next part is the limit as x approaches -1 of our function has to exist. And so that means as you approach -1 from the left and from the right, are you getting closer to the same value? So as I approach -1 from the left, headed towards -1, now I'll just write it out. The limit of f of x as x approaches -1 from the left would be 1. That has to be equal to the limit of f of x as x approaches -1 from the right. So when I look at the graph, as I approach -1 from the right, I'm getting closer to -1. These are not equal, so this limit does not exist. And if the limit does not exist, if the limit does not exist, then it's not continuous. So the limit of f of x as x approaches -1 does not exist. So f of x is not continuous. And I should say here, it must exist, right? And it didn't, so that's why it's not continuous. Okay, so now when we look at x equals 1, okay, so first of all, we ask ourselves, does f of 1 exist? Yep. At 1, the y value was this blue point, it was 1. Yes, right? F of 1 equals 1. And then we ask ourselves, does the limit of f of x as x approaches 1 exist? Which means, is the limit of f of x as x approaches 1 from the left equal to the limit of f of x as x approaches 1 from the right? So as we approach 1 from the left, we get closer to 1. As we approach 1 from the right, we get closer to 1. So is it true? Does it exist? Yes. The limit of f of x as x approaches 1 exists. I'm sorry, my handwriting is like really terrible right now. All right, and then the last criteria was that f of 1 had to equal the limit of f of x as x approached 1. So this was 1, this was 1, they're the same, okay? And then since all three criteria are met, the function is continuous. Since all three conditions are met, f of x is continuous at x equals 1. All right. Then what else did this ask? I feel like it asked for something else. All right. If h of x equals f of x minus 3 plus 4, graph h of x. Okay, so you might look at that and say, what? That sounds terrible. Okay, but all this means is I'm going to take everything to the, not to the left, it's minus, right? We take everything to the right 3 and up 4. So I'm going to kind of just pick, you know, like these key points that I had, and everything is going to go to the right 3. So like this guy here is going to go to the right 1, 2, 3, and it's going to go up 1, 2, 3, 4. And then from there, I had like the 0.11. So I'm just going to go over 1, 1, and then I go back 2 and up 1, 2, 3. Right. And so I know that was just a parabola. I'm just going to be grateful there's no stretch here. That would really be nasty. Okay, and then really from there, I could just say, okay, to get this piece, I've got to go, you know, down to and just kind of replicate it. Or I could take each of these and say, okay, now I'm going to go to the right 3, 1, 2, 3, and I'm going to go up 1, 2, 3, 4. Right, and then I had this point. These were all diagonal, right? But then there was a point of inflection, and then it just went to the right. So in black here, that's my h of x. And then it says write h of x as a piecewise function. Do not forget to change the domain. So that just means in up here, rewrite h of x as f of x minus 3 plus 4, which you might look at that and say that seems really complicated. But if I just say f of x minus 3, it means anywhere here where you see an x squared, that or an x rather, you're going to put an x minus 3. So you'd have x minus 3 squared, but then you have this plus 4. We'll come to this domain here in a second. All right, then again, f of x minus 3 means if you see an x, you're going to put in x minus 3, and now this is cubed, but then plus 4. Here there's no x, it's just going to stay 1. And so when we change our domain like this, it just means this is not starting at when x is -1, because everything moved to the right 3. Now this starts at 2. So it's like basically I just had to add 3 to all of my x values here because everything got shifted. So this would be x is less than 2, right? -1 plus 3 is 2. This would be, okay, -1 plus 3, that's 2 less than or equal to 1 plus 3 is 4. And then this would just be bigger than 4. 1 plus 3 is 4. Okay, so it's bringing in some transformation stuff from earlier this year. All right, 163. Approximate the slope of the line tangent to the curve. F of x equals -5x squared plus 10 at x equals 9. When you see this slope of the tangent line, you should be thinking instantaneous rate of change. As soon as you see that, you should be thinking, I have to take the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, now I know in this case that x is 9. So I'm going to put 9 in for x. And when it says f of 9 plus h, that means here and here, or just here, right? When I see that x, that I am going to substitute in. So I have -5 times 9 plus h squared plus 10. This right here, that's my f of 9 plus h minus f of 9, which means put 9 in for x. So -5 times 9 squared plus 10. Notice I have this in parentheses because I need to subtract everything all over h. Please, please, please do not be lazy about pulling through the divide by h in every step. Some of you are kind of doing stuff and it's like really one step is not equivalent to the next step if you don't carry that h through, if you don't carry that limit all the way through to the end. Okay, so when I square this 9 plus h, it's 81 plus 18h plus h squared. And then this is what -5 times 81 plus 10. When I figure out what all of that is, oh gosh, let me write it down. Nuts. Sorry, I usually do. And I don't want to think about it. So 5 times 81. Which is 405. So this is -405. And then this is minus 10. No, plus 10, sorry, plus 10 all over h. And then I distribute. All right, so again, I'm carrying it through. So this is -405 minus 90h minus 5h squared plus 10. This would become plus 405, then minus 10. And see, if you don't bring those, put those parentheses in, you will not subtract the 10 and those will not cancel because remember, it should be that these numbers always cancel. And then here between these two that I have left, I can pull an h out. and then these cancel. And then I'm left with the limit as h approaches 0 of negative 90 minus 5h. And when you can, what you want to do to find the limit as h approaches 0, your first strategy is to put that in for h. The only time you can't do that is if the h were a fraction, and then you have to go to the graph. But here we can do that. So the slope of the tangent line is negative 90. So what that means is if I were to have graphed this negative 5x squared plus 10, which is this really steep parabola, and then at 9, I drew the slope of the tangent line, it would be negative 90 would be the slope of that line. If I drew that to scale, it would be really steep. Okay, 164b, we were asked to solve the triangle. Just doing part B in this one. So that means find missing sides and angles. The first thing I would do is, I see this angle, I would find the side across from it. I don't have enough information for law of sines because I would need 2 angles. So law of cosines. So law of cosines, I'm looking for C. So C squared equals my A squared plus my B squared. So 4 squared plus 7 squared. Now I know technically this is side A, and actually let me call it that. You're probably like, why are you calling it C? It's C in the formula, right? I'm trying to find side A. Side A is across from the angle I know. So this is A squared. So the other two are the A squared and B squared in the formula. A minus 2 times A times B times the cosine of 50 degrees. And I could just, because these are all numbers, I could put those all in, and to get rid of the squared, I could take the square root and just put that all in at one time. Now before, remember, you had to be in radians. Now you need to be in degrees because that's in degrees. So just be careful on that. And you get 5.39. Now, once you have that, now you can go ahead and use the law of sines. So I can set up a ratio with those, and I could do the sine of 50 over 5.39 equals, now just go ahead and find something else, like the sine of angle B over 4. And then I would cross multiply, so I would have 5.39 times the sine of B equals 4 times the sine of 50, and then I would divide by 5.39. I really wait until the very, very end to actually put any of this in my calculator. Like I would in my calculator, literally, I put this in, but then I'm not done because I want to know what angle B is. So to get angle B, I would have to do the inverse sine of both sides. So I would have that angle B equals whatever the inverse sine of all that is, which is 34.65 degrees. And then to get my remaining angle C, I would just do 180, take away the 50, take away the 34.65, and then that would give me the 95.35 degrees for C. All right, 165 vectors. So we want, remember these symbols here, I mean the magnitude, when you see this, magnitude. But first I need to figure out for part A, what vector that 3b minus 7w is. And then I can find the magnitude. So I need to do 3 times the -6, -1, and then minus 7 times the 8, -9. So then that, it's basically like distributing -18 minus 3 plus, I'm going to distribute the -7 in and change this to plus. So that would be -56 and then 63. And then I end up with -74 and then 60. That's my component form. And I want the magnitude. And the magnitude is the square root of a squared plus b squared when your vector is in that AB form. So I need to do the square root of -74 squared plus 60 squared, which ends up being 95.27 for my magnitude. B, direction. Direction, remember, is the inverse tangent of B over A when you have something in component form. So again, I'm going to get this in component form. So I'll do 6 times the 8, -9. What is that? Plus 2 times the vector V, which is the -6, -1. So then I would have 48 and negative 54, and then plus the negative 12 and negative 2. And then that gives me 36, negative 56. So if I were to draw this vector out, 36, negative 56 would be somewhere down here. It's a fourth quadrant vector. So I'm going to do the inverse tangent of this is my A, this is my B, of B over A, which gives me negative 57.26. And yes, that is in the fourth quadrant, but remember the direction for vectors is going counterclockwise from standard position, which is the positive x-axis. So I need to add 360 to get my direction angle. So when I do that, I get 302.74 degrees. All right, 166, which is just a lot of practice with rationals, which we needed a lot when we were doing all the simplifying with trig functions. So here I need a common denominator. So I'm going to multiply here, top and bottom, by A minus B. I wrote the wrong thing. I think I'm going to write it a little bit here also. So here, the first one, I'm going to multiply the top and the bottom by A plus B. And here, I'm going to multiply the top and the bottom by A minus B. Parentheses. Okay, on the top, I'm going to go ahead and distribute. So I'll have AC plus BC. And then up here, I'll have AC minus BC. And on the bottom, I have A minus B times A plus B. These are opposites. These are like terms, so 2AC. And this is difference of squares. Remember, if you have A plus B times A minus B, it equals A squared minus B squared. So that's just A squared minus B squared. Done. All right, now for B. All right, a common denominator. You see, this has a 3 and this has a 6. I want that 3 to be a 6. I need to multiply that by a bottom by a 2 to turn it into that denominator. And this has an x, but that has an x squared. So if I want them to be the same, I need an x. So 2x times 3x would be 6x squared. So I don't need to change this fraction. So here I have to multiply the top and the bottom by 2x. So I would have 2x squared plus 4x minus, I have to subtract this whole thing. I'm going to just rewrite it in parentheses, and then over 6x squared. So I have 2x squared plus 4x minus x minus 1, all over 6x squared. Again, important to carry your steps all the way through. Don't say, oh, I'll just put the 6x squared back at the end. It's sloppy. It's not being precise. 4x minus 1x is 3x, and then minus 1, and nothing cancels. You can't like reduce anything. You are done. All right. Okay. Ooh, so we're going to factor and divide. I'm going to factor as I go. So here I see these both have a 4x as a greatest common factor. So I'd be left with x minus 2. I notice this is difference of squares like we talked about over here. This would be x plus 3 times x minus 3. This is division. So I'm going to do two things at once. I am going to factor and flip at the same time. So this, I would have a greatest common factor of a 2x squared, and I'd be left with x minus 4. Just making sure I'm writing this down correctly as I go. It would be so sad, right? And then this would factor into what? X minus 4x plus 3. Yes. Okay. So then what can I get rid of? This. What about like here and here? I could get rid of an x here. This, and I'd be left with an x, and 2 goes into 4 twice. So on top I would have 2 times x minus 2, and on the bottom I would have an x and an x minus 3, which you could leave it like that, or if you want to expand it, knock yourself out. So either of these would be fine. One more. Okay, we're multiplying. So I'm going to think of this as over 1. This is difference of squares, so x plus y times x minus y. And I'm just going to keep it over 1 and keep everything lined up. Up here, I could pull out a 4 and an x from everything. So I'd be left with x plus y. And then on the bottom, that would be what, x plus y times x plus y. remember we had the rule that we use sometimes when we were doing the average rates of change and the instantaneous rates of change, that this, when you have perfect square equals this. And I'm just noticing that pattern here. Oh, this is 280, sorry. Okay, I'm just noticing that pattern there. And then what can I get rid of? I can get rid of this here and here, and this here and here. And I'm just left with a 4x times x minus y. Or if you wanted to write 4x squared minus 4xy, you could do that as well. All right, closure, always such a long, long, long video, but you need it.